Hello. So I'm Tom Dyar. I am product manager in the data platform side. I'm joined by Alvin, Ryanputra, that you might have seen on the main stage today. We're going to talk a little bit about chatbots and GenAI, which how many people are sick of hearing about it at this point? Okay, thanks, Alan. I knew someone like you. Anyway. All right, so anyways, it is fun stuff. Hold on. Why did that not work? Okay, good. So we're going to talk a little bit about GenAI, what it is, where it is in this framework, what is RAG, which is Retrieval-Augmented Generation, how vector search fits into that, a little bit about the roadmap. This thing has a real delay. Come on. Maybe I need to be closer to it. Oh. All right, so overall, as you probably know, machine learning sits within the whole artificial intelligence realm. And within machine learning, there's obviously different categories of things. And traditionally, of course, tabular ML has been what people have focused on, doing classification, regression, clustering, very narrow use cases, narrow problems where you have some data and you try to train a model to do a very specific thing. And then, of course, image recognition, survival analysis, other kinds of statistical techniques could be considered machine learning within that. But generative AI is just a little bit different off to the side. It's really related to large language models, which are, of course, if you've heard on the main stage, trained on basically all the public data. And vector search is part of that kind of story in the sense that once you train these large language models, they can be repurposed for multiple things. And that's what vector search is, pretty much a repurposing of large language model learning over all of that text. And once you have one of those large language models and you can do all these different use cases, it kind of changes the paradigm to, instead of training a bunch of different models, you kind of reuse one big model for a bunch of different use cases. And also, earlier you might have heard some of these kind of drawbacks. You know, you train this huge model over all this data, and then once you train it, it's already out of date. So as you see down below, the 4.0 cutoff date is October 2023. And you know, you have some limits to the size of the input you can do it. For each large language model call, you have, of course, a token limit. And that really drives the use of vector search, as we'll talk about, because you can't pass in your entire database into one large language model call. You have to subset your data. So, and some other challenges, of course, with generative AI. It's a vast infrastructure. There's definitely an access problem. Only OpenAI, Microsoft, those big billion-dollar hyperscalers can really do this. Once, of course, you train it, you can use it. And open source models are getting more and more capable all the time. They're distilling them into smaller and smaller sizes so they can actually run on laptops now. So that is becoming a thing to look out for. They hallucinate. And it's just basically, they're just trained to predict the next word. They have no reasoning, no filters in their head. I have a very small filter. Sometimes I just say stuff, right? But large language models have no filter. They just say whatever. And actually, when they train them, they have to specifically edit out things that they've learned in their training, hate speech types of things, cuss words, because they're just outputting right away. That makes them relatively fast. So they don't have to go through a bunch of loops of thinking about things typically. But in order to get all of those filters and get that real thinking type of behavior out of them, you do have to call them multiple times in the context of these applications. And retrieval-augmented generation and agent types of applications are how you do that. But, and also, as part of that data problem, they have problems with the bias. And if you say something a little bit differently, they might respond completely differently. So everything has to be tested quite a bit to overcome these problems. And I thought this was really interesting. So it was this week or maybe just last week. This is a really kind of, it's a hyperbolic wording, but it's really quite impressive what they did. So you see this, this kind of question that they asked. They made a new benchmark. Alice has N brothers. She also has M sisters, and then they would change those numbers for different examples, and they'd have similar kinds of logical questions. How many sisters does Alice's brother have? Or how would you calculate that? And the answer is M plus 1, because you have Alice is going to be a sister, as well as M, as in Mary, of her sisters. Large language models don't do well with that. They cannot even answer those questions. The breakdown is dramatic. And they also, the models express strong overconfidence in their wrong solutions while providing often nonsensical reasoning-like explanations akin to confabulations to justify and back up the validity of their clearly failed responses. So it's something to look out for. And really, the proof of what they're saying here is by looking at the performance of two different benchmarks. So you have the MMLU on the y-axis. So this is the standard benchmark that all of these models, they do pretty well at, right? They're up in the upper echelons of that. Depends on which model you're talking about. But this new benchmark that they came up with, these very, very simple logical questions, almost all of them failed. GPT-4o did better, but it's still about half correct. So this is something that's going to, you have to keep in mind. These things are not really thinking. They don't really have logic. They've just been, they've been cajoled into that, and it's really a big problem that we'll see some advancements. I hope so, but something to look out for. All right, so one of the ways that you can cajole and trick large language models into sounding more intelligent than they really are is this retrieval-augmented generation pattern. You've seen this slide a lot, but really you have to talk about vectors and what they are. They're the output of these embedding models. Similar semantics, similar words are going to, that mean similar things are going to show up in similar parts of the space. And of course, it's a very complicated space. We're just showing 3 out of 300 dimensions here. And you definitely get some benefits with these. They're compact, they're general. Of course, you could have embedding models that are image-based or multimodal in other ways, like multiple types of data could be used to train embedding models. And it turns all the search and similarity search into just nearest neighbors, a simple geometric operation. Of course, there's challenges. Every time you update your data, you're going to have to update your embedding representation of that data and manage that whole process. So within retrieval-augmented generation, really it's just about bringing your data to the large language model and kind of customizing the response of a large language model from that general point to a more specific something about your data. So if you start with your data, you got to build a knowledge base. And the way you do that is you split up each one of these documents into some smaller chunk of data. And then you vectorize it with one of these embedding models. That makes a vector. It's a long string of numbers. It's one of these points in space that other similar documents or similar chunks of documents is going to be close to. And then you put that in your vector database. You do that with all of your documents. They're going to show up in those different places. And now when you have a question, right, you have a query. So you do the same thing. You make a vector out of it. You don't know what that vector is at the beginning, so every time you have a question in your application, it's going to have access to that embedding model. And the same embedding model has to be used on the query as was used to index your data, because each embedding model is slightly different. It might have different number of dimensions, or it was trained differently. Like I said, you can have image-based ones, so it could be totally different. So you have to keep that the same between the query time and the indexing time. And then when you do your search, you're just looking around that that point that you got from your query. You retrieve the actual pieces from your original data. I think I have a bug in my animation. Sorry about that. So then you go back, you get those original chunks, and then you stuff those into the prompt. So you have a prompt that says, answer the question. Only use the stuff that I'm giving you now. If you can't find the answer there, don't answer. Please don't answer. Someone's going to die if you answer incorrectly. Something like that. Actually, that will change the output of your large language model if you threaten to kill somebody. So it's very interesting kinds of behavior you can get out of these things. And then answer the question based on that. And so that goes to your large language model, and then you get it back. That's just a general pattern. There's a lot of variance on it, and I'll talk about a couple of those, and we'll see how that works in action. But that really kind of, the short of it is that for RAG, you're using this vector search. It's semantic search. It really is powerful. It reduces the hallucinations if you have a good prompt and you tell it not to hallucinate. It doesn't cure it completely because, like I said, that they're just, hallucination machines almost. And then this brings it utility for everybody because you can use your own data with it and keep that data secure if you want to. So now I'm going to pass it over to Alvin. He's going to talk about how this looks in actual IRIS.
Thank you, Tom. So what I'm going to tease now is kind of like a new feature that we will launch either 24.2, 2024.3. So it's a new embedding SQL function, and I've showed it on main stage. I'm just going to go a little deeper into it, and I'm going to also talk a bit about how to improve your RAG pattern. So what we really want to enable is IRIS Vector Search in 4 commands. So the first step to use this embedding function is just to create an embedding configuration. And it's really simple. I'm just inserting something into the table with my API key, various configurations, and choice of embedding provider. The second step would be to create a table. Note that the first type is just a standard string, and the second one is of type embedding. And then that calls the specific configuration that I set, OpenAI 1. And that's going to create embeddings on the content column. Third step would be to insert your data, and it's as simple as just inserting whatever's inserting into the content column, because the embedding is going to be automatically generated each time you insert or update your data. And then you can already query with embedding. As you can see, it just uses an order by vector cosine. You can also use vector.product. So another way to do it, would be just to use load data from CSV, and you can insert an entire data set of documents into your table. So I want to talk about some syntax improvements compared to what we have in 2024.1. What we have now is a 2-vector function that will still work, but you have to, convert this vector into a string and then insert it manually. And you would have to do this kind of programmatically. So at the bottom is the new embedding function, and that already abstracts away anything to do with vectors. So you can just query it really easily using SQL. And this is also another comparison. On the top, we have what you would do with 2-vector, and at the bottom with embedding. And so no more vectors in your SQL statements, fortunately. So we have completely abstracted away vectors. We have a hybrid search that's really native and well integrated with SQL. And all your embedding endpoints will be stored centrally in embedding.config, which makes it easy to really configure and track in the future. So I'm going to show you a little demo, which is a little similar to the one I did on main stage. So I'll just put a logging on the side. So what I have here is a table of information of companies in the S&P 500. So let's say I'm searching for, give me 5 semiconductor companies with more than 5 billion in revenue. So this will do that flow where the query is converted to a SQL query. On the left, you can see. So this does a hybrid search where revenue is more than 5,000 million and ordered by vector cosine. And now I'm going to talk about, let's see, compare Micron and KLA. And so it tells me a lot. Yeah, so that's just an SQL query. So what's really powerful about this flow is that with a routing layer, you can do so much more with your chatbots. I'm going to go into a... You can do a lot more with your chatbots when you have an additional routing layer at the beginning. But before that, let's go through quickly the flow of how I set this up. First, all the data into InterSystems IRIS with the embeddings created. After that, the user gives the query to the chat UI. We have a text-to-SQL layer, which converts the query to a SQL query. And what I can do in this layer is that I can also say, oh, if you think this does not require SQL, don't do a SQL query. I could also add more instructions to it. I could say, if you would like to use an API, say something. And I can programmatically choose an API instead. I could even get an LLM to tell me what arguments to put into that API. And so what we're looking at is a spectrum between a regular RAG flow to something that's slightly more agentic, where a large language model is deciding what it should do based on the query that you give it. So in my demo, I only have kind of two flows. One is to convert to SQL. One is just no SQL. So for example, if I ask something that does not require anything from my database, it's just going to say no SQL, and it'll just send the message history and try and talk to me based on the conversation history. But there's so much more you can do over there. But regardless, the main idea is still grabbing relevant information and then feeding it back to the large language model. And there you have it. This is a really simple RAG demo that's very effective. So now that we've heard a ton about vector search and RAG patterns, I think we can kind of delve into something slightly more advanced. So if I have a RAG flow set up, what are some ways in which I can improve it? So the first step would be to identify, is the problem with your retrieval or is the problem with your model? Now, if the problem is with your model, you can tell when the information that you retrieve is plenty. A trained human, would be able to answer the original query using all of that contextual information. If that's the case, just use a more powerful model or use a fine-tuned model, for example. On the other hand, if your retrieval is the problem, then it becomes slightly more complicated. Let me go backwards. We can start first with your choice of embedding model. There are various sizes of embedding models that will influence how long it takes to convert your data into embeddings. So over here, I've used OpenAI's embeddings. You can use a variety available on Hugging Face of a variety of sizes, in which there are also trade-offs with speed and kind of domain expertise. Because you can choose an embedding model that's especially fine-tuned for a medical or law domain, for example. The next thing you could add would be, after retrieving the relevant context, to include a re-ranking layer to kind of make sure, maybe if initially I just pick the top 50, I pass it to a re-ranker that re-ranks it to something more accurate using a cross-encoding model. That will give you, and then from that new ranking, I now take the top 20. And now I really get very, very relevant information to my initial query. And finally, another way to improve it would be what I talked about with routing, which I did over here. You can, for example, if this query is of a certain kind, use this table. If not, use that table. Or also, if you recall, okay, it's okay, I wouldn't switch to it. When the large language model creates a SQL query and does a similarity search, it's also doing some sort of like this concept called hypothetical document embeddings, in which it kind of tries to guess what I'm trying to search for. So if I was searching for a semiconductor company, the search query could actually be a really long description of what a semiconductor company sounds like. And that's going to give me better results when I do that similarity search. So I could go on all day about this, but there is a variety of techniques that you can go into. But with what we have in IRIS Vector Search already, you will be able to do plenty. And next, Tom is going to come back and talk about even more RAG variants.
All right, so thanks very much, Alvin. Yeah, so RAG is great, but it is just a pattern, and there's plenty of things going on in research realm, and these are just 3 of them that I'll just talk about a little bit. One of the things that can happen is that your query could not be quite right. Someone says something, but there's many different ways to say it, so there's a real simple kind of solution to that, which is to generate more queries at the beginning. Try a bunch of those, and then rank them all together after you make multiple queries. So that is one way to do it, because typically the actual similarity search could be done with a cheaper model and before you actually generate a response with an expensive large language model. The other variant that I'd like to talk about is Raptor, which is really interesting. So it recursively summarizes. Really the problem that it's trying to solve is that there could be very long documents that have relevant context, relevant to the query, all scattered throughout it. So what Raptor does is initially clusters all those documents in chunks, clusters the chunks so that the relevant ones are together, and then summarizes those clusters. So you get a document, or kind of like mini documents that are a collection of different parts of a larger document, and then you use a large language model to summarize those, and then you index the summaries. So that way, no matter where the relevant context is in the document, it should come back against the query. So that's a relatively complicated setup, but once it's all coded up, it really doesn't matter. It just becomes another index type. That's something that could easily be built on top of IRIS Vector Search. It's at a different level of the abstraction. So, and then corrective RAG is another one. So sometimes you can tell, you use an evaluator model, you can see over on the left. So first off, you evaluate whether or not the answers you get are correct. So you kind of go through a search, you look and see if they're correct. If you're pretty sure that the response that you got, or the results that you got, were correct according to kind of a ranking model, then you go on that green path. If you're not sure, you do both. You actually go along the green path, but then you knowledge search. You could actually kick out to the internet and search that and see if you get your answer there. If you know you're not correct, if you know you have context that's just not related to the query, you just kick out to the internet. And so that helps to give you better results. So those are things that are out there now and easily implemented within any kind of RAG application. Just a flavor of like what people are looking at and what's happening in the research world. So I'll talk a little bit about our roadmap. Overall, we want to support Retrieval-Augmented Generation in all of those forms and be able to support a really high quality application, very rich application, frameworks around. But InterSystems IRIS overall is going to focus on the lower part of this diagram. We're not training large language models. We don't have those kind of resources. And we'll leave that to the hyperscalers. But within the platform, we definitely want to have a really wonderful vector database capability, which IRIS Vector Search is starting that. It's not there 100%. And we also want to focus on the prompt and the context parts of it to really help with application development. So according to those things, we have at the lower level and over on the left, vector search, storing embeddings, doing the fast similarity search. That's a platform feature. That's for developers. In the middle, templates, like a RAG toolkit, some of this embeddings index. is kind of the first start of that, what Alvin showed, and it's coming out for solution builders. And we'll have more things that will be installable kind of separately from Iris, as well as those built-in things like the embeddings. And then we are also building copilots. Of course, you saw on the main stage some different examples of that throughout our product stack. That's for end users and will probably and very likely be provided as a service. So that is the roadmap overall, kind of at a high level. But now as a timeline, we have an early access program. However, in 24.1, vector search is an experimental feature. It'll be a full feature in 24.2, but for now it's experimental. And in 24.2 as well, we'll have the embeddings index that Alvin previewed there, that really just abstracts away vectors. You don't have to think about them directly. And then a very major thing that will be coming this year is an approximate nearest neighbors index, and that helps with scaling across billions of vectors and just making it a really scalable vector search capability. So that is pretty much it. Open it up for questions. Thank you very much. Anyone? No questions, Richard? Okay, after. All right, well, you can come up to me and Alvin. We're regular people. You can talk to us anytime. Thanks so much.